Hi, I'm Guang, 15 years old. In this lesson, we have the techniques of definite integration. So, we'll be taking a look at this example on this board here, which we are asked to find the value of this integral, which you have to integrate x squared plus y squared plus z ds on this boundary C. And what is so special about this boundary C? So it will be defined as a part of a helix, and this helix is given by this position vector is cosine t, sine t, t. And the part we're specifically looking at in this example will be t greater or equals to 0, smaller or equals to 2 pi. Right, so this is the question. Now, first of all, we need to know what kind of a question is this. So of course, when you take a look at this boundary here, you have 3 separate coordinates. So these 3 coordinates, they'll of course be respectively the x coordinate, the y coordinate, and the z coordinate. So when the x coordinate is cosine t, the y coordinate is sine t, and the z coordinate is t, you might be able to form some kind of an image within your head. And of course, since it is also given in the question that this here is in fact a helix. So let's start thinking about this. How can you determine what does this helix look like? So of course, firstly, you already know the x and y coordinate, what they look like. So x is equal to cosine t, y is equal to sine t. Now, one way to think about this helix is, let's say you just take a look at them, you don't care about the z. So what do you see from there? If x is equal to cosine t and y is equal to sine t, on a 2D surface, that's just a circle, isn't it? A unit circle, or a circle with a radius of 1. But what will be so special about this kind of a thing? So now that you know, from the top, when you look down on it, there'll be pretty much a circle. So how about you add in the third coordinate, which is a z here. So instead of just a circle on a 2D plate, now you have a circle that is gradually rising, isn't it? So that is one way you can try to imagine how this helix look like. And of course, if you need a model to look at it, this will be an example of how this helix looks like. So of course, since when you substitute your values in, you might realize that the x starts at 1, the y starts at 0. So of course, you can look at it from this way. So if here is your y and here is your x, so x you have starting from 1, which is your 1, 0, 0, then it gradually spins in a circle while rising upwards. And of course, since it stops at 2 pi, it will make one entire turn before it reaches, well, before it ends, alright? So of course, this helix, this is more of a regular helix, alright? So what do I exactly mean by regular? So of course, helixes, maybe they can be slightly slanted, or if you have learned something like from biology or DNA, a DNA is a double helix. So all those kinds of things. Alright, so let's take a look at how this will turn out. So, first of all, what do you want to use to find this or to solve this question here? So, first of all, we might have to determine what our ds is. Since, to determine this integration, we need to know what exactly are we integrating with respect to. So of course, firstly, we'll start with what is ds. So ds, well, of course, that will be a combination of all 3 of the coordinates, but how exactly do you combine all 3 of these coordinates? So you do have an x coordinate, a y coordinate, and a z coordinate. And looking at this kind of thing, which is your position vector, can it give you any sort of a clue to how you can find this ds? Well, of course you can, since your ds you can determine it by using a square root, dx squared plus dy squared plus dz squared. Alright, so how do you get this square root dx squared, dy squared, and dz squared? Since you need to bracket them out in order to be aware of what is d what exactly? Is it dy and then squared, or is it d and then y squared? Alright, so how do we look at how you get this ds here? So of course, you're given x, y, and z coordinates. So how you can determine it is essentially, let's say we have a miniature cube, alright? So it could be a cube, it could be a cuboid, well, it all works. So x coordinate, let's say it is this side here. So let's say this is the x, this is the y, and of course upwards will be the z. So how do you get this step here? So ds, what it essentially will be, is from one vertex to the opposite vertex. So it will be in this direction here. Right, so how do you break this down? Now if you have learned like physics, dynamics, kinematics before, so what you will realize will be that you can separate this into three different components. So you have an x component, you have a y component, you have a z component. So essentially x, y, and then z. So of course then you can just use Pythagoras theorem to find it out. Alright, so that is how you think of this ds. So now we have to determine what each of these are, isn't it? So dx, what can you get from this? So of course dx, you look at x and you have a cosine t. So you have a cosine t. What would be so special about dx then? So that's what you essentially have is negative sine t squared. And if you still don't get how you get this, well, you essentially just differentiate it. And next is your dy. So dy, your y is sine t, which means you get cosine t, and then squared. So last but not least, you have your t, which then when you differentiate is just 1 squared. Right, so what do you get out of this? So of course, if you're fast to realize it, then what you'll see here is, whoops, I'm missing a step here, since if you have your differentiation inside, since differentiation is d something dt, outside here would essentially be dt. Since you multiply in the denominator, you have to multiply in the numerator again. Sorry about that. So yes, this is essentially what you will get. Now, what will be so special from this step onwards? So if you realize it, you have a sine squared t plus cosine squared t, which is 1 by your identity. So 1 plus 1 will just be 2. And thus this gives you square root 2 dt. Alright, so this should be what your ds gives. Right, so what next? Now that we know ds is square root 2 dt. Well, from this step on, you should be pretty confident in getting what kind of a boundary you have, which is 0 to 2 pi, or if you want to write the question in front, you can do so. So integrate around this boundary, x squared plus y squared plus z, and then ds. So this will be equal to integrate from 0 to 2 pi. So x squared, you just have to substitute in what you're given here, which is cosine t squared, and then you add y, which is sine t, and then of course square it, then add t, and this would be, originally it is ds, so you can add a square root 2 in front to make it dt. Alright, so this is the integration that you will be dealing with. Now let's simplify things a bit first, shall we? First of all, square root 2, is on the outside. Then integrate from 0 to 2 pi. So inside here, once again, you'll see this identity, which is sine squared t plus cosine squared t, which is 1. And thus, you have t plus 1 dt. And now, what does this become? It's just a simple integration question, which will give you square root 2. So t inside here will become half t squared, and 1 becomes t. So this you have to substitute in 0 and 2 pi. So when substituting 2 pi for the first term, you have square root 2, 2 pi squared plus 2 pi. So of course when substituting 0, that's just 0. So this just gives 2 square root 2 pi plus 1. Alright, so this will be the answer that you get. Now, you look at this answer and it looks a bit weird, doesn't it? What does this exactly mean? So, what this exactly means would also depend on the kind of context of question you're given. Well, in this case, it is not exactly given, so it is more of a generic, specific thing. So, what do I mean by that generic, specific thing? So, first of all, what does integration complete? What integration does is, let's say you're given this specific area, this specific volume, and this integrand here will essentially mean what kind of density you have in there, or a specific whatever that you're trying to find. For example, charge density and all, right? Charge, mass, whatever. So then, after you integrate, you'll get the overall of that something. Could be mass, could be charge, it could be many different things. Alright? So it all depends on what kind of question you're given. So in this case, this will be the amount of that specific something you have. Alright. So another misconception that you might have here will be more of its meaning. So since just now I've already explained how this is more of calculating a different thing which may or may not be given within your question. So many people might confuse it as this will be the length of that helix, which is not right. So this will only be finding the length of the helix if your integrand is 1. So what happens when your integrand is 1? Well, when your integrand is 1, that will just be, so you just won't have this entire part here. So if you can see it quickly, that's just 2 square root 2 pi, which if you really can't see it, this will be a different thing. So you do have your integrand, that will just be ds. Then you just have square root 2 integrate from 0 to 2 pi dt, which will just give you 2 square root 2 pi. Alright, so this is actually your length of the helix. So remember this thing? Yes, its length would actually be 2 square root 2 pi, which if you found the circumference of a circle before, that is only 2 pi. Oh, isn't it 2 pi r, so why is it not? Well, that's because this is a unit circle, so radius of 1, but if it is just 2 pi, well, you're not accounting for your extra height in it, if you get what I mean. So if you can think about it more on Pythagoras theorem and all, which will give you the extra square root 2. Alright, so that will be pretty much it for this lesson here. I hope that you are pretty much clear of this example here on how to solve this kind of integration. So what you essentially do is you try to change the something at the end to fit into your parameter. So of course, this parameter will be the main thing you're focused on, and try to change whatever's inside into that parameter, unless you have some special cases which we will discuss more in the future. Alright? So I hope for this lesson you're clear of everything so far. I'll be ending it here, and thank you for your watching.